So this is chapter 14 on global climate change from the Essential Environment textbook. And this chapter is talking about global climate change as a whole. And it starts off the chapter talking about the rising sea levels that are threatening Florida. And there's a video that have included in my PowerPoint called South Florida and Sea Level Rise from the Yale Climate Connection. It's a grouping of different news reports that explain the situation. And if you look even in the comments section of that on YouTube, you see different residents' take on what is happening. But basically, as the sea levels rise here in California, I don't think that we notice it as much, but in some places they have noticed it a lot. And specifically, Miami has raised their roads about 3 feet. They also have invested in a lot of things like sandbags and pumps to pump water out. And in their higher tides, water is coming up into their city and flooding to where people, have a hard time even moving and getting out of, some really close beachfront property. So climate is specifically the long-term atmospheric conditions in an area, whereas weather is different. That's more like the day-to-day or hour by hour, what is happening as far as the weather at the moment. And things that can affect both of these are temperature, precipitation, that's like the rain or snow, wind, humidity, the pressure, and different like sun conditions, solar radiation. So these are basically always changing, and global warming specifically refers to the increase in the Earth's average temperature that has happened over time. So there's a few different factors that affect climate. One is the sun. So some areas of our Earth, like at our equators, is sunnier all the time. The atmosphere also plays a major role in the temperature shifts that we have from day to night. And then our oceans, they store a lot of our heat and keep us at a very temperate like stable temperature. If you live near the ocean, they will store a lot of heat and carbon dioxide. So the sun is where we are getting nearly all of our energy on this planet, and some of it is absorbed and some of it is reflected back off, which goes into the greenhouse effect. And I have this video called What is the Greenhouse Effect by NASA's Space Place, so you might want to check that out if you are not sure about how the greenhouse effect works. But basically, we have different molecules, and it's molecules that come in groups of three, like water has two H's and an O, or ozone has three O's, that will basically absorb a lot of radiation from the sun. It'll absorb the bad, radiation that we don't want, and then it will um, reflect a lot of the heat and warmth and keep it back inside of the earth to keep us warm and to keep us at a moderate temperature. So they rate different greenhouse gases based on their ability to reflect heat or keep it in, or their greenhouse effect or ability. And they always compare it to carbon dioxide. So if they say essentially if carbon dioxide has a value of 1, meaning it will hold heat in near the earth and keep us warm, and it's a 1, then methane is actually 84 times stronger, which is like, here the cow is actually farting. So in this video, that is a gas. So methane is actually 84 times stronger, and nitrous oxide, which is like a laughing gas, is like 264 times stronger than a molecule of carbon dioxide. And then hydrochlorofluorocarbons, which are, commonly used in refrigerants, they are much stronger. Let me go back up. It was like 10,000 times stronger than just one carbon dioxide. So the dangers of that. So a lot of the human generated changes, a lot of human activities have caused more of these chemicals to be in our atmosphere. So, since the Industrial Revolution, carbon dioxide, nitrous oxide, methane have just shot way up where they were a lot less before. And I'm sure you wonder how, and we will talk about how they can determine that later, or what records they have. So, um, different fossil fuels or carbons actually change form as they rotate through, like the geosphere or the atmosphere. So the um, in the ground, or like on Earth, they can be in like the carbon form, like in different living things. In the atmosphere, carbon can be CO2, so it can take different forms. One of the things that CO2 will do is it will actually absorb into our oceans. So, generally that trees or plants use carbon dioxide as part of their photosynthesis process, and they give off oxygen that we can breathe. But our oceans also become what's called a carbon dioxide sink, where they absorb a ton of carbon dioxide. This acidifies our oceans, and they will become basically a reservoir or a carbon sink. Nitrous oxide is due to mostly fuel, like auto emissions, and feedlots, different nitrogen fertilizers. It is also something that is absorbed back into the atmosphere, and it creates greenhouse gases. Now, some climate change is actually very natural and it varies on its own. So there's three different ways that this can happen. One can be like an axle wobble or shift, a slight variation in tilt, and sometimes just based on where the Earth is in its orbit is going to change the climate at the time. However, these shifts are like very, very small compared to what we are seeing with global climate change as a whole. Um, Oceans, we've talked about them, but oceans actually hold 50 times more carbon than the atmosphere. Most of the carbon that we have is sunk into the ocean, and it's creating an ocean that is slightly more acidic and warmer than it should be. This creates a problem for things like corals that corals would otherwise be clear, but they take on zooxanthellae, which are a tiny plankton. The zooxanthellae have color, so when they move into the coral, it will give the coral its color. As the zooxanthellae respirate, because in response to the light and heat that is coming down into the ocean, as they respirate, they also make waste. When the oceans get warmer, they'll actually over respirate and over make waste, and the corals will actually expel them because they can't process all the waste from that zooxanthellae. When that happens, the coral takes about a month to starve to death because it's not getting those nutrients from the zooxanthellae, and it dies. Then the coral is said to be bleached because it has lost its zooxanthellae that gave its color, and it also dies. So it's a very sad process, and it's one of the examples of how climate change isn't necessarily first affecting the largest things, it's affecting the smallest things, which are the basis of our food chain. Okay, so there's different ways also that the climate can naturally vary. One is from thermocline circulations, like how the oceans are circulating, really alters the climates in the areas that it affects. Greenland also has melting ice sheets. There's the El Nino Southern Oscillation, which we've talked about in a previous video, and different atmospheric shifts. There's a great video on this called The Gulf Stream Explained from Kyrgyzstan, so I recommend you watch that for more information. So we talked about a little bit ago, like how do scientists even know what particles existed in the atmosphere 100 years ago or even 1,000 years ago? How could they possibly know that? So scientists look for different proxy indicators. So they look for different things that they can measure from the past. There's actually a really cool study about this called abrupt climate change during the last ice age. And it's a graph, it's a study from Nature Education from the Knowledge Report. I recommend you look at it because it explains that not all variations in climate take thousands of years, that sometimes it has happened very abruptly and very quickly. So one of the ways that scientists find out what the weather and air atmosphere was like long ago is they can take out cores from glaciers, because glaciers are formed over long periods of time, and they do trap different particles like air bubbles that are from the atmosphere at the time, and they maintain that record in the ice. So as scientists core down, they can see what was there. Some glaciers in Antarctica date back 800,000 years, and they can see what the atmosphere was like over time. So those ice cores are studied and preserved, and scientists can see what existed and compare it to what we are seeing now. Another direct measurement that scientists take is by using different monitoring stations to find out what the atmosphere is like in different places. So I put a picture of an erupting volcano. Um, Mauna Loa is in the Big Island of Hawaii, and it is the tallest mountain on Earth. From the base of it to the top, it's the tallest, like that way. And it is out in the middle of the island and far away from everything else, and that has been studied greatly because of the fresh air that's there. And we can see from that data that carbon dioxide concentrations have increased from about 315 parts per million in 1950s to 415 today. So we've increased by about 100 parts per million in about 70 years. So scientists will make these different climate models to help them predict the future of what this is all going to look like. Models are usually pretty unreliable because lots of different factors that can affect them, but they do their best with the models. Average surface temperatures have risen about 1.1 degrees in the last 100 years. That doesn't sound like that much, but that's a couple degrees Fahrenheit. And again, it's affecting the littlest things, not the bigger things. Like the whales aren't in the ocean aren't necessarily affected at first. It's like the plankton at first, and then everything up the line. Okay, so we've also seen an increase worldwide of precipitation of 2%. So while we are having in Southern California a lot of years of drought, or tend to have a lot of years of drought, there's other places that are raining more. Um, so the warming has been greatest in the Arctic. That has slowed down what is called like the jet streams. Like here's a normal, typical jet stream and how it should cross across the United States. But this warming in the Arctic is making this jet stream go like this. Well, it doesn't seem like a big deal, except that it's making colder weather and warmer weather in places that are not typical. It's also causing different glaciers to melt. I have a picture here of a glacier. Here's a glacier that's like slow ice moving down. And here's the same mountains. This is in 1911. This is in 2009. So almost 100 years apart. And the glacier has melted here. But you can basically see that once the area starts to have the ground exposed, the darker ground actually gets warmer faster than the ice, and so it speeds up the melting process. So it actually accelerates itself as it melts, it goes faster and faster. So scientists expect that the western Antarctic ice shelf, if it continues to melt, which they're seeing that as being somewhat inevitable, it could raise oceans as high as 3 meters, which is a lot. Here's a video that you can watch on the changing Arctic ice, and it's called Disappearing Arctic Sea Ice from NASA's Climate Change. So check out that if you have time. So the rising sea level does actually affect people that live in areas that they're not that high off of the ground. In the last 135 years, our oceans have risen about 9.5 inches, and 9.5 inches doesn't sound like too much, except there's these countries like Maldives that their high point of their country is about a meter off the ground. So it's only about waist high above ground is the majority of their land. So they do have a lot of spaces where it's just built on stilts, because that's what they need to do in order to have space. So we've already talked about how the oceans become acidified with carbon dioxide, and we talked about how this acidification affects marine life, especially like the coral. I would highly recommend watching this How Scientists Are Restoring the Great Barrier Reef from Travel and Leisure. When I worked in Australia's with their Great Barrier Reef Marine Park Authority, we did work very similar to this, so I know that these are things that are actually being used in the field. So, personally, what can you do about climate change? Just always be pushing to get more energy efficient products. This suggests eating less meat, or instead of going for beef, eating something like chicken that lets off a lot less methane gas, reducing your commute, which I think most people are okay with that, cutting back on waste, and engage and vote for things that will do that. This is a cool video about carbon capture and storage. There are different machines like those that can create like a little interior rain system and catch those greenhouse gases and make an acid rain that can then be like dealt with internally. And this one is uh, called Backed. Carbon capture plant does the work of 40 million trees by CNBC. So it's an interesting video to watch. Also, putting a price on carbon and having companies pay for the carbon emissions that they have is called a carbon dioxide tax. So usually those prices are passed on ultimately to the consumer, but then consumers that want something that's really um, really contributes to greenhouse gases is going to pay more for it so that it can be cleaned out of the environment later. And if it's worth it to them, they'll do it. And if it's not worth it, they'll find alternatives. So, one regulation that has been put out there is called cap and trade. And cap and trade is where a cap on emissions is set. So if you emit more than that, then you have to pay heavy fees. And if you emit less than that, there's smaller fees. And so that encourages some companies to really cut back their emissions, but that costs them money to make those upgrades. But then they can sell their permits for their overage to other companies that are going over. So they end up recouping some of their money from selling their permits to other companies. That's called cap and trade. We've noticed some people think that the government shouldn't really be involved in this that much. So there's been a lot of debate about that, nationally and internationally. Um, in um, International emissions have not been reduced or changed that much, but we have quite a bit in the United States. We've actually reduced our carbon dioxide emissions by 13%, and during the same amount of time our economy has actually grown quite a bit. So we've gotten wealthier, but we have also invested in a lot of green energy. So instead of making us poor, we've actually gotten richer at the same time. In California specifically, we have a goal to cut the greenhouse gases by about 25% by 2020, and we're past that now. So I would expect a new report on that soon. But in general, this is gross domestic product. That is like how much like goods that we make in our country and our population. So our population has grown, but look at compared to our gross domestic product has really soared since 2000 when we really started targeting these emissions. But our emissions on different levels have all declined. So while our emissions have gone down, which is great, our population has grown. So we have more people, but less emissions. That's awesome. We also have grown our domestic product. So I guess it kind of it adds another piece into the argument, like when people say, it's going to cost us a lot of money to do these things. We've actually seen as a country that we've done better even with these changes.